Hello. This is our kinematic extravaganza. I'm Matt Forrest, this is Brent Malley and Alex Ray. We're here to show you our final procedures and development of our BRG. So we've been having some technical difficulties with brightness, so there are some charts that are not showing up as well on the camera. So the submitted slides we've sent in, you can follow along with those and see everything we're talking about. Hopefully it will not be too much of a problem.
So this is our updated Gantt chart included per ritual, and as you can see, hopefully, we are at end of December or beginning of December in the presentation final results stage, which is going to be concluded after we finish this presentation. And so when we were looking at this Gantt chart throughout the project, we did actually go back and arrange some things that were allocated less time than was needed, and the most prominent of those would be the concept generation. We had originally estimated that to only take about 1 week, but in realization it took almost 3, so we went ahead and made that update to the Gantt chart to present the final scheduling.
So the team went back through the failure modes and effects analysis with those 2 highest RPN failure modes to further address them in our BRG. And to do this, we took the poster board that was originally designed for the Y joint and used cardboard on the base to keep it more level when the ball impacts it. And then we kept the poster board for the loop and the ramp leading in. That way friction would be reduced in that critical area.
So one area of emphasis that we really took seriously throughout the project was our design for environment, as we believe that most companies do have a responsibility to help our ecosystem survive, as it's where we and all of our companions live. So one thing that we took into account was recyclable materials, and so that's why we made our BRG and also the packaging components much greater than 80% recyclable by mass. So what we mean by that is our BRG is made almost exclusively of paper products. So the only things that aren't reusable to the fullest extent are the adhesive materials used to connect different obstacles and different structural members, and also the Arduino component. And so we extended that to our packaging as we used cardboard packaging. Ultimately, it is the consumer's job to be sure that they take advantage of the recyclability and reusability of the machine and its packaging, but we have provided the means for them to do so. So we've also extended our product to make a common platform, as we've employed the slot modular architecture in our BRG. So the way it works is we have a main structural component to which different obstacles can be attached. However, it is slot modular because we cannot interchange the obstacles at different positions. They have specific connections, and those must be adhered to make it work properly. So if VTEPS chooses, they can develop new obstacles that maybe aren't included with the original BRG package if it is a hidden market.
So for the industrial design stage, we created and planned the kinematic extravaganza focusing on a couple different categories, namely the quality, the uniqueness, the user happiness, and the maintenance and repair. The entire BRG is the only one of its kind. There isn't a product on the market right now that uses the obstacles and challenges combined with educational objectives in physics for high school students as ours does now. So that was a big thing. We've gotten very good results for user happiness with the way we have created it. And it's good quality, it's very sturdy, even with the recycled materials used. And because it's a slot modular design, and because it's made of recycled materials based off paper products, maintenance repair is very, very simple. So this was all created to help the the consumers kind of get their money's worth for buying our product. So for the drawings of our main components, here you can see we have the Y joint, we have the Arduino track switcher, we have the ramp into the loop, and we have the ring catcher. So basically this is just a computer design drawing of the main components of our entire BRG. So the ball will come into the Y joint and will travel until the track switch, and the student will have answered questions that will then control the Arduino and send it either to the right or left, which will then send the ball either towards the ramp in the loop or towards the ring catcher.
So there is certainly opportunity for improvement within our design if we were to extend this product in the future, or if there was a need to develop it into the next generation perhaps. So one of the things that we were thinking could be improved would be the use of materials, as our design tends to have a higher coefficient of friction than we would like, as a lot of energy is lost from top to the bottom. And also there are things that are also reusable to maintain our high reusability, but may be more structurally sound than cardboard components, or have a greater longevity. And also, as we, as team members, progress through the MA curriculum here at Virginia Tech, we hope that we will eventually learn more about these different materials and how to employ them in designs such as ours.
So, for the assembly time overview, the team kept our assembly simple and using common materials. Doing so allowed us to keep our times for assembly low, even to the point where our final assembly time was just over 3 minutes, which gave us an extra 2 minutes of time to make sure our BRG was set up and working correctly for our final presentation of the BRG in class. For the assembly time and cost sheet, values for assembly costs and assembly time were found. These give us an estimate of what production may look like. For the cost sheet, we went through and found the price of these materials that we'd be buying in bulk, because on a full production scale, that's what we'd be using, and then estimate what the labor cost would be for our workers that would be assembling our BRG. We also found that through this cost sheet that our BRG only costed around $4 if you exclude the Arduino component in total for assembly and for material purchases.
So that concludes our presentation on our BRG Interkinetic Extravaganza. You can look for it in the market. Hopefully it'll be out there. Thank you for listening to our presentation. If you have any questions, you can reach us at any of our emails. So thank you.